in the link state routing algorithm, we are going to study the Dijkstra algorithm. So in case of the Dijkstra algorithm, it says that network topology, uh, the network topology link cost known to all nodes. Okay, so topology and that the cost from a node to the all other nodes is going to be known, and that is going to be accomplished via the link state broadcast. So all the nodes are going to be have the same information, okay, about the topology and about the cost. So say it computes least cost paths from one node source to all other nodes. So that means here we are going to be consider a source node in a network layout, and we should need to be find out from that source node to all other nodes available in the network. That means all other nodes are going to be our destination, and we are going to be uh, discover the least cost paths from source to every other nodes that are available in the network. All right. So now here say that gives forwarding table for that node. Okay, and iterative after k iterations, no least cost path from path to the k destinations. So here on, forget about this, the left part, come to the right part. This is the most important part that we need to understand. If you understand that, then it's going to be easy to understand that how the Dijkstra algorithm is going to be work for finding the least cost path from source to all other available nodes in the network. So here the cost of x to y, this is the link cost from node x to y, and if that the node y is not that the direct neighbors, then we are going to be use that infinity sign. That means it's unknown. Okay, so if it is happening like that, okay, this is that nodes. So these are the two nodes are directly connected, but this node is not the node y is not connected with x directly, so suggesting that, I mean, the y, so for the x, it doesn't know about that the y, so we are going to be using the table the infinity sign, that it's an unknown node for the node x. The dv means that the current value of cost of the path from source to destination v. So for example that the current path here, say that it is the 2 cost of x to w, and say that it is 1, say that it is 3, okay, and say that it is 1 1. So that means first of all, the x is going to be count these two nodes, the I and w. So if cost, the current cost is going to be from x to w is 3, but when uh, you are going to be, so you are going from x to w is 3 and x to I is 1, but when that it will go from I to w again, so the cost is 1 plus 1. So that means the later on the cost of the path from that a node to that another node, in this example x to w, it can be found the least cost path. So it's saying that, so what is the current value of cost path from the source to destination? So when it is moving from x to w, it is keeping the record that the cost of this path is 3. So this is going to be the current value, and later on that is going to be changed. So that is going to be the updated value, because with this path you have find out a least cost path compared with this the current value. So that means that is going to be updated in the table, that okay, least cost path is 2. We'll see that in the example, so don't worry. And it is here that the PV means that predecessor node along path from source to V. Yeah, so what is that the predecessor? You can think like it's a past node, previous node. Okay, so if you're considering that the first of all, when you start from x to w, so to come to the w, who is your previous node from the w? Who is your predecessor node from the w? It is x. Okay, so it is x, so that is going to be the PV. And when you actually update that the path from x I to w, On that time, who is going to be your previous node? I. Okay, so that is what that the PV is, that it is along with the path. So when it is keeping that in the table, the cost is 3, the predecessor node is X. So when it is going to be updated, that time it is going to be 2, the cost of path is going to be 2, 1 and 1. And on that time, the predecessor node is going to be I, something like that. Okay, and in here that in bar, that set of nodes whose least cost path is definitively known. Okay, so let's check that. I mean, it is going to be very clear in this example. So you can see that we are having a network layout graph. So here we have considered that as is the source. So we are having that total excluding the ace, we are having the 5 nodes. So that means we have to find the least cost path to from ace to all that the 5 nodes. All right, so now let's start it. So for each of the nodes is excluding that the u, because it's source, we are going to be start from here. So each of the nodes are going to be need to have that this dv and pv. Okay, because we are going to be found that dv and pv for each of the nodes from the source node. So we can see that, I mean, you are having the here x, w, v, y, z. So you can actually for each of the nodes you are having, that you can actually put it here in any combinations, in any order. Okay, not necessary that you should need to be right here v first, then w, then x, then y, then z. But it's better that you start with that the direct nodes, right? So that, I mean, where you can go directly. For example, here in this example, that you can see that from the u, you can go to the x directly. So the link, that is the link, black color, and then you can go come directly to u to w and u to v. So it's suggesting that these are the 3 direct nodes. So it's better that you write these 3 nodes at first. Okay, in any order. You can write wxv or xwv or vwx, whatever, in order. Any order you can actually write them. And then you are writing that the rest of the nodes, y and z. But if you are doing that, I mean, you are writing y and z first, and then you are writing them, then also no problem. Okay, let's start that. I mean, these are our direct nodes. Okay, so we are having that for each of the nodes, we are having the dv and pv, d and p, right? So that is here that d and p. Okay, so that here the node name is v, so it is dv and pv. We are having for w, dw and pw. We are having the x, the dx, px. We are having the y, dy, py, and we are having the z. We are having the d, z and pz. So from that. We want to start from u, so let's start from u. If we want to go from u to v, that my first node is v here, so I want to go from u to v, come to the graph. So you can see that u to v, if I'm coming u to v, then my cost is 7. So that I have written 7 for dv is 7 current value. And who is the predecessor now? That is the u, so comma u, pv is my u. Okay, I have written that as because I can go from u to v directly. So can I go u to w directly? Yes, I can go from u to w directly. So what is the cost? That is the 3. So I have written the 3, and this is my dw value is 3. And what is pw, predecessor node? That is u. So comma u I have written. And can we go u to x directly? U to x, yes, I can go u to x directly. What is the cost? My cost is 5. So I have written here the 5. Okay, so that u to x, dx is my 5. So who is my predecessor node? From x, that is the u. Okay, previous node is u, so predecessor node is u. So for p x, I have written comma u. So now, can I go u to y directly? Look that from u to y, I don't have any direct link. The y is not my direct neighbor. So that means I do not know that at this moment it is unknown that how to go to, how you can go from u to y. Then the next node is my Z. So can I go U to Z directly? No. It is also not a direct neighbor. I can do not have that the direct link. So that means it is also unknown. So now in this row, the zero step in this row, that the values you have found for that, for going from U to the different nodes, from these values, you should need to be find out who is the least cost. I mean, which number is the, minimum number out of this, the three values you have got in this row. So out of these three values, who is actually that, which one is that the having that the minimum number. So you can say the 7, 3, and 5. So I can see that my minimum number is 3. So that means I'm going to be take this path. Okay, I'm going to be take this path means that I'm going to be take the W for my next node, from where actually we'll continue the searching, list cost path searching. So that is why I'm taking the W. So you can see that next one with the U, I have added here W. So that means now we want to start from the W. So we have selected this node from this row number 1. We have selected the W. So from this node now we are going to start the search. So let's start it. So you have to understand one more thing here, that it is fixed. That means I have taken that U to W. If you want to go, then this is my least cost path 3. So I cannot get less than or least cost path than this, because I have taken this uh, granted it as my next node. So that means that path has already defined. So that means U to W path is now found already. That is the cost of 3, and predecessor node is U. So we have selected the W, the node, as in from here now we are going to start the list searching for the least cost path to the all other 4 nodes. So now you can start from W to V. Can you go from W to V? Yes. What is the cost? 3. And the value, the W we have selected from U to W you want to go, the value you selected 3. So here that the 3, that the value you're having, that must need to be added with this the link cost between that the U to W to V. Okay, so as because we are searching from W, so that means to come to the W from U, the cost is 3. So that the 3 must need to be added with the
স্যার
other. Yeah, exactly. Yeah, please carry on.
স্যার স্যার এই যে নাম্বার ওয়ানে যে ইউ এবং ডাব্লিউ ওইটা স্যার একটু রিপিট করবেন, এই যে নাম্বার ওয়ানে ওইটা কেন দিচ্ছে স্যার, ইউ আর ডাব্লিউ দুইটা একসাথে কেন?
Yeah, so this is what I'm saying here on that, from this row, that the values you have find, you should need to be check who is having that the minimum value. The here you are having 7, 3, 5. So who is the
So
minimum
three
value?
is minimum.
3 is minimum, right? So
Yes,
that
sir.
the 3 is we are taking. So if the 3 you are taking, it belongs to which node? W.
Yes, sir. W.
So that's why you have taken the W as a next node, from where actually you'll start the restart the searching. Okay. So it is fixed. Already you have taken U to W, the cost is 3. So this is going to be the minimum cost. Okay, it's done. For the W, we are not going to be search anymore. So from the W, we are going to be start for the next other nodes list cost path. We are going to be search. So as because you have selected W, look that you have selected W and that your predecessor node is U. So what is the cost that you need to come to the W3? So if you're going from the W to any other nodes, so that the link cost of those links is going to be add with that the 3, because you have to come from W to X or W to V you want to go, you have to come U to W and then to them. So that means the cost is need to be add.
Sir, can you please repeat it, sir? I didn't understand.
Yeah, so what we are saying is that we have taken the W as granted, right? That I mean we have found that the least cost path between the U to W, that is the 3, cost of 3. Now we have taken that the W for that for the searching the least cost path to the all other available nodes. So now if you're starting for W, so that you want to go W to V, so you want to go W to V, so what is the link cost? 3. And with that 3, you must need to be add the 3. Why you
We
have to
have
add the
to
3?
add the previous one.
Right, exactly. So you have to add the 3 here. So that means it is going to be 3 plus 3. It is going to be 6. Do you understand that or not?
Yes, sir. Yes, sir. I understand.
Right, right. So now if you're coming to that W2 V, then it is coming 3 plus 3. 3 you are having here, and the link cost is 3. So that means 3 plus 3, it is 6. So if
Yes,
it
sir.
is 6,
6.
you did that the, I mean, less than that the value you're having here. That earlier you have found U to V is 7, and now you got
Yes, sir.
right. So that means it is least cost, right? Compare with that the previous value, the current value we are having in the table. Now that the new path is giving me the cost of 6, so it's suggesting that it is the least cost compared with that the previous one, isn't it or not?
Yes,
So
sir.
that means this is actually updating. That's why we are writing here 6. And now if I'm taking that the this link, that W2V, then who is my predecessor? I'm coming to the V, so my predecessor node is W. Okay, so that is
Yes,
why
sir.
I'm writing that 6W. Is it clear or not?
Yes, sir. It is clear.
All right. So
But
now
in
you can,
sir, step 1, we are also writing 5U and 11W. It's not
yeah,
clear.
we'll go there. We'll go there. Is it clear for W2V or not?
Yes, sir. It's clear.
Right. Now we are going to be moved from W to X. This one is already done. As I said, this one is already done. So we are going to be moved from W to X. Is there any direct link from W to X? Yes. We are having a
Yes,
direct
sir.
link.
4. And
Yeah,
previously
because
we
The
have
phone
6.
number path.
It
so
can be 10.
it is 4. No, 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 no. It's not going to be
7.
10. It's going to be 4 and 3. 4 plus 3.
7.
Right?
Yes.
Do you understand that or not? It's going to be
Yes,
4.
sir.
We are coming U to W and W to X. So it's going to be 3 plus 4. It is
4.
going to be 7. Understand or not?
Yes, sir. Now it's clear.
Okay. So what was your previous value? 5.
5.
Right? So
Yes.
7 is greater than 5. So that means we are not going to be change, update the table value, right? It is going to be as it is. Understand or not?
Yes, sir.
Yeah, right. So now if you're going from the W to Y, do you have any link? Yes, you're having a link W to Y. So what is the cost? 8. So
8.
8
And previously
plus
we have
3.
3.
Right.
And
So
it's
8 plus
11.
3, 11. Right. So this is what we are writing 11. So you
Yes.
want to come to Y. So from where you are coming to Y? From W. So your W is your predecessor node. Understand or not?
Yes,
So
sir.
Y is W. Clear?
Yes, sir. Clear.
So from W to Z, can you go from W to Z directly? No. So it was unknown and still it is unknown. Okay. Now from this row, you have to find again that what is the minimum value. Which node is having that the minimum value? So we can see that is 5.
Yes, sir. It's 5.
Right? 6, 5 elements. So 5 is my minimum value. So the next node I am going to be, so this is 6, that how to go to the X, for you to X. Okay. And now I want to take that the X, I have selected the X as a next node. Okay. From the X, we are going to be continue the searching to the other nodes. Now you coming to that the X node. So if can you go, so where is that X? It is that the X, right? So you're going to be start from the X now. So if I'm starting from the X, then from the X, can I go to the V directly? No, there is no link, direct link from the X. This is my X and this is my V. So there is no direct link, okay, from between that the X and V. So that means I kept the value as it is, right? So I had the 6W, I'm keeping it as it is. So now I'm going to be moved from X to Y, okay? Can I go from the X to Y directly? Yes. What is the cost? 7. Okay, what is in my hand? That is my 5, right? This is the 5 I'm having here. This is my 5. Okay, so 7 plus 5, how much it is coming?
12.
12. What is the current value? 11. So that
11.
means it is not going to be updated, okay? Because this 12 is larger than 11, right?
Yes, sir.
Greater than 11. So that we are keeping that as it is, 11W as it is. Can I go from X to Z directly? Yes, I can go X to Z directly. What is the cost? 9. And what is in my hand? 5. So
5.
9
It's
plus
14,
5.
sir.
It is going to be 14. So that you can say that I have written here 14. The DZ is actually 14. And from that the j from to j from where we come, that X. So X is my predecessor node. The PZ is actually my X node. Clear?
Yes, sir.
Yeah, right. So now in this row, again, I have to check that the minimum value. So I am having 6, 11, 14. So out of these values, 6 is my minimum value here. So I'm going to be take this now. All right. So if I'm taking this now, then which node it belongs to? Node V. So that means node V I'm going to be take as my next node. Okay, so this search is going to be continued until we get the least cost path for every other nodes. Okay, so now I have taken that the V node, this one I have taken the 6 here from this row. So V, from V will start. In my hand, how much I am having? 6, remember that. So from V, can we go to the V to Y directly? These are already found, the
So
V
yes, sir. We can go
VW.
from V to Y.
Right, so V to Y, can we go directly V to Y? Yes. So what is the cost? 4. And what
4.
is in my hand? 6.
6.
Right?
It will be 10, sir. Now it
So
will
it is
be
coming 10. So what was that the previous value? 11. So 10 is the smaller than 11. So that means it is going to be updated. So my dy is 10. And from V actually we come to, sorry, from where we come? Yes. From V, we go to the Y. So that the predecessor node is going to be my V, right?
yes, sir.
So that the PY is my V here. So now can I go from V to Z directly? V is here, Z is here. No, there
No,
is no
sir.
direct link is there. So Z is not the direct neighbor of V. So that means the value we found earlier, we kept that as it is. So now out of these two, this is my minimum value 10 and 14. So that means we are going to be take the Y as the next node, or from we are going to be search the path to other nodes. So if I'm taking Y, so what is in my hand? That is the 10. From Y to Z, can I go Y to Z directly? Yes. What is the cost? 2. And what is in my hand? 10. 10 plus 2, it is 12.
12.
What was my previous value? 14. So that means 12 is smaller than 14. So
We are
so
updating
it is
it.
going to be updated. Right. It's going to be updated. So that I'm writing the 12 as a DZ. And from where I came to Z? From Y. So that Y is my PZ. Okay. So in this row, we are having the only one value. So we are going to be take the Z. Right. So that's how we have finished all that the nodes available in that the graph. Clear?